We're recording page 6 of the 5-3 notes. And here we're talking about interpreting graphs. So using the graph of f to draw conclusions about f prime and f double prime. So this is a way to kind of connect it all together. So obviously this is a position graph, okay, of a particle moving in a straight line, even though this graph is not straight, but the particle is moving in a straight line, just that sometimes the particle is going to have a position of 1, then a position of 2, and it just kind of does in this fashion. So here's the question. At approximate times, the particle's velocity equal to 0 and acceleration equal to 0. Well, remember, velocity is a derivative of position, and acceleration is a derivative of velocity. So acceleration is a second derivative of position. So when the velocity equals 0, that's when s prime, or y prime, or whatever you want to call it, equals 0, and this is when s double prime equals 0. When s prime equals 0, remember, you're going to have horizontal tangent lines. Where do I have horizontal tangent lines? Those places right there. Okay, so we could probably say roughly 0.7, 2.5, and maybe 4.5. I'm just kind of roughly estimating. So that's part A. So again, you're looking for horizontal tangent lines. That's all. Okay, this is the part you have to be really, really careful about. When you want to find an acceleration is 0, it's not quite a point of inflection, but you're kind of looking for points of inflection. So essentially what you're doing is you're kind of eyeballing this. You want to see where s prime changes from increasing to decreasing, or vice versa. So what do I mean by that? Well, right now, that green line, that's a negative tangent. Of course, that's a 0 tangent. Of course, that's a positive tangent. However, somewhere in here, f prime starts to decrease. Somewhere between the first tangent line and the second tangent line, because clearly my derivatives are increasing in value. And let me actually clear this right now. Let's use green highlighter. Right now, my derivatives are increasing in value until I got to somewhere over here. Then my derivatives start, or f prime starts decreasing in value until I get over here. And then they start increasing in value again. So the green represents intervals where f prime, or slopes of tangent lines, increase in value. The red is vice versa. Intervals where f prime, or slope of tangent lines, decrease in value. Because like if I drew a tangent line right now, right here, that's positive, and then 0, then negative. So in that red region, my intervals for my f prime is decreasing in value. Well, what that means is that here, f double prime is positive, concave up. Here, f double prime is also positive, concave up. But here, f double prime is negative, concave down. So we tend to see, so we call these points of inflection. And so I probably would say the expression is going to be 0 somewhere in that region. So that's why you have to eyeball it. So I probably say maybe 1.5 maybe, and maybe like 3.2 is probably where the expression would be 0. So it's a little bit of eyeballing you have to do. So that's how we can use the graph of f to draw a conclusion about f prime and f double prime. You're trying to see where you're really getting granular with the slopes of the tangent lines. Not just where the slopes are positive or negative, but also when the slope is changing, when the slopes are increasing in value, then all of a sudden they start decreasing in value. That's point of inflection. We would expect f double prime to be 0 there. Or the other way around, your slopes of the tangent lines are decreasing in value, then all of a sudden they start increasing again. That's a point of inflection as well. Another way we tend to interpret graphs is using the graph of f prime to draw conclusions about f. That is a huge, huge deal. This right here is kind of the essence of week 3. When we get to week 3, which is actually going to be probably our most important week of the semester, that's kind of the essence of what we're doing this semester, especially in week 3. So this is f prime graph, okay? Remember, this is an f prime graph. And f prime equals 0 at these 3 places. So that probably is good to know. F prime equals 0 at x equals -3, 1, and 5. Also, we see that f prime is positive from -infinity to -3, and also from 5 to infinity. And I'm going to use open bracket or open intervals because obviously f prime is 0 at -3 and 5. You know, it's not positive or negative there. And f prime is negative from negative infinity to 1. You don't include 1 because it's 0 at 1, and 1 to 5. So
Mr. E, would f prime be negative from -3 to 1, not negative infinity to 1?
Oh, shoot, you're right, sorry. Yes. Thank you. Thanks for paying attention and catching it. So now we can answer these questions. Where are you increasing? When f prime is positive. Where are you decreasing? When f prime is negative. So you're not looking at tangent lines. You do not look at tangent lines at all. Don't look at tangent lines for f prime graph if asked where f is increasing / decreasing. Instead, look at the y values. That right there is what you need to do. And so it's really a mindset thing. You have to look at the y values on the f prime graph to answer parts A and B. I already did it for you anyway. I did it up here. F prime is positive from -infinity to negative. So the graph of f would be increasing because your derivative is positive in that region. We'll try a sketch graph of f afterwards, based upon these results here, and we're decreasing here as well. And then estimate your local extreme values. Well, we have remember f prime is positive here. Actually, let's get a little highlight or color coded. F prime is positive here, F prime is positive here. F prime is negative. . and all these different intervals here. So at x equals -3, that's a local max because you're going from positive to negative. At x equals 5, that's a local min. At x equals 1, it's neither min nor max because you don't see a sign change. Question in chat? I think so. You can do a sign chart. Someone's asking about sign chart. Sure. Yeah, and really you're just copying what you see in the graph. So there's positive here. There's negative, negative, positive. Yeah. Yep. That is going to be a max. That is going to be a min, and nothing's happening at once. It's just stationary. So could I try to sketch a graph? I mean, I don't know any particular y values for any particular x coordinates. Because I should say, oh, f of 1 equals this, or f of 2. I should say that. But yeah, I could kind of do a rough sketch here. Maybe if I just select some of the stuff to delete. And let's see here. Yeah, I could try to do a quick sketch. Like it's supposed to be increasing value until I get to -3. So here's -3. So it's supposed to hit a peak and be increasing the value. And then it's decreasing, and it kind of flattens out 1. So it's going to maybe do something kind of like this here. And it's going to keep decreasing until I get to 5. And that's a min. And then it's going to start rising again. Question in the chat? Absolute, that might be kind of tough because you need a little more information about like a particular y value, like endpoints, stuff like that. I think finding absolutes would be tough here. And rarely if I ask, I mean, unless you have endpoints, it's rare to be asked absolutes here. But the College Board does definitely get very creative. But I don't know if you guys are ready for that yet. Those really kind of odd creative problems, because you guys just learning this. This is stuff that we'll do in the post session after session 1's over, and now you're in session 2. But we have the AP study groups. That's when we're going to start infusing a lot more AP stat. And when we do AP review in April, because we're going to have a couple days. So again, even after February 5th, you're not done with me. I'm still going to be present, but just we don't have quite the same structure that we have right now. But that's when I'll start getting a little more creative with the kind of things I'll ask, because that's the College Board gets creative with their these topics. But yeah, that's kind of what's happening here. Another thing that's kind of interesting too that you can kind of look at. What if I did draw tangent lines here? What if I did? Like, what if I drew a tangent line like right here, and right here, and right here, and right here? Well, what's happening is that, and I'll use a highlighter here, is that my derivatives are increasing in value until I get to somewhere over here. Then my derivative starts decreasing in value until I get somewhere right there. Then I start increasing in value again actually, yeah, no, I'm looking at this the right way. So we can make a conclusion about concavity. It's kind of hard to tell, but like, for example, where you see that boundary change around like maybe -1 or so, that might be a point of inflection. Remember, this is my original graph right here that I did in orange. And maybe we're seeing probably another point of inflection, probably somewhere right there. And perhaps I'm seeing another point of inflection, probably somewhere right here. And actually what you're really looking at, to be honest with you, when you're doing the tangent line of an F prime graph, I got too much going on here. When you're doing a tangent line, so here the slope of F prime is negative until you get to here, right? So what this means is that F double prime is negative from negative infinity till about like maybe negative 1.7, let's say. We'll call it negative 1.7. Because you're doing the tangent line of a derivative graph. The tangent line of a derivative graph, and I'm gonna really kind of spend a lot of time scaffolding and what's the other word to use, spiraling this into future lessons. The tangent line of a derivative graph is F prime, sorry, F double prime. And then all of a sudden, the slope of F prime is positive here, then the slope of F prime is negative here, and so forth. So that's how you have to kind of look at it. But I don't know if we're quite ready for that yet. So I'm gonna kind of hold off on that. But this is kind of putting it all together. Like obviously here, this is a differentiable graph. It's nice and smooth and connected. Here, like y prime is 0. That's increasing. Here it's decreasing. Y prime is less than 0. Concave up. Those are examples: concave up, examples concave down. Inflection points. That's concave up right here, concave down right there. Because your slopes are increasing in value until you get that inflection point, then you start decreasing the value of your slopes. You look at how y prime changes sign, for local mins and maxes. That's part of second derivative test. So there's just kind of more just examples we can look at. Let me do this. Let me start the worksheet with you guys and kind of give you a little bit of a push, and then you guys can work on it later today. Homework's very updated. I don't have to do anything to put out. There's no videos to watch. Really, what you should do is you should do the textbook problems that I've assigned. You should do the worksheet, worksheet 3, and you should look at the study guide. So let's forego this example for now. I don't think that's, maybe we could talk about it tomorrow, but I don't think I'll directly assess you on this. I think I'll maybe set for next week. But let me look at the worksheet, and I'm going to keep the recording going so you guys have this to watch. So this is something I could ask in the free response question tomorrow. I say, here's F prime. Where's the local extreme occurs? Where's increasing and decreasing? Where's the concave and concave down? Give me the points of inflection. Sketch a pulse graph of F. Something I could ask. I think it's a good question. So let me kind of give you a little bit of a head start here. We'll give you some hints. For part A, again, I am recording this, and I'll make sure I upload this recording ASAP. Where does local extremes occur? Well, that's when F prime equals 0. So you already have F prime. So just immediately set that equal to 0. Factor out 4x. Solve for x. And then you should do a sign chart.
Mr. Almalshny, it's 12x squared.
Oh, you are correct. Sorry. Yikes. Okay. So we update this. We're human, we make errors. Thank you, Eleanor, for telling me. Yes. So 0 and 3 then. My bad. Okay. Now, we'll do a sign chart for the F prime. So if you plug anything bigger than 3, like say plug 4 in, our derivative is positive. And x minus 3 is linear. So you do see a sign change there. X equals 0 comes from x squared. X squared is a quadratic term. It's a squared term. That's not linear. But if you plug in -1 anyway, or anything less than 0, you're going to get a negative derivative regardless. So there's no sign change there. So for part A, you could say that you have a local min at 3. And I might have a solution key. I'll look one up. If not, I'll have to do that later today. Yeah, let me look it up, see if I have a answer or a solution key for that one. For part B, where it's increasing or decreasing, remember f prime is negative for this. For that, f prime has to be positive, so you should know to do that real easily. Concave up, concave down. Remember, f double prime, you got to find that, which is easy. That's 12x squared minus 24x. Set equal to 0, factor out 12x. Do a sign chart for your second derivative. Remember, f double prime, concave up. Sorry, f double prime positive concave up, f double prime negative concave down. Points of inflection when f double prime changes sign. And do your best to do a graph. And I'll share my graph with you guys tomorrow when we go over this. So that's part of the worksheet. If you guys want to work on it later today, you can. Again, I am recording this, so don't worry that I'm about to clear the screen. Question in the chat. You have to do union. Someone's saying for decreasing, yes, you have to do this, -infinity to 0 and from 0 to 3. You can't do this. You can't say that because 0 is not a negative derivative, so you can't say that. So you have to do like this as a union. Great question, Lauren. Thank you for asking that. So sorry, I'm going to clear the screen because we're in class in a couple minutes. For the study guide, just so you know what we've covered, just to kind of make sure I've hit all these topics here. Have I talked about extreme value theorem? Yes, you got to be continuous and closed interval critical points we talked about. How to find them, you got to test the endpoints and the critical points in the original function. Mean value theorem, we talked about you got to be continuous on a closed interval and differentiable as well. We did a worksheet on that. Geometrically, it's when the slope of the secant and tangent are the same. You should be able to write those out. We did do I know we didn't talk about antiderivative in the homework, but we could save that for tomorrow. We did some stuff with linear motion with that in one of our lessons. We did do all these things here. First derivative test we talked about. Second derivative test we talked about. Increase and decreasing we talked about. Concavity we talked about. How to determine it we talked about. Points of inflection we talked about. The required AP language we've talked about. How to get a graph of f prime, how to use graph of f prime to obtain a graph of f we talked about. And that's part of the worksheet. And also just putting it all together, we talked about. Yeah, and then, yeah, I don't know what's meant by blue worksheet 15. Let me actually update this. That's weird, but these extra problems are good ones to do. Yeah, let me update the file and delete that because that seems weird. But yeah, we've gone over all the stuff. So look at the study guide, try looking at the test from last year, do the textbook problems, which I have right here. I'm going to make some copies as well. Try this worksheet. I gave you guys a little push on that. So those are the things we're going to want to work on tonight. I am available. Well, Ms. Valk will be available 8:15, 8:45. I'll peek in as well if I'm not busy trying to get the test written. We'll see if I'm, working up to the last minute. But of course, we'll do a review from 9 to 10 o'clock tomorrow morning, and then we'll do the test after that. Okay, Well, I'll stick around if anyone has any questions right now. I'll stick around for maybe another 10 minutes or so. Otherwise, then you guys are free to go enjoy your lunch, and I will see you guys in class tomorrow.
Thank you.
Goodbye.
Thank you, Mr. Reed.